Welcome to my YouTube channel. And this channel is probably specifically about machine learning and machine learning projects. I myself, as a data scientist, practice machine learning every day. And today we're going to be looking at a very simple project. And in this series, we'll look at more complex projects as we move on. The first project that we'll be taking a look at today is a regression based project. Now, what the project entails is that first we're going to be performing some regression. For context, those who all don't know regression, regression is the act of predicting future values based on current values, right? But that is just a simple explanation. How do you apply that to data? That's how we're going to be looking at. As you can see in my screen, we have the first basic inputs. Now, as such, this is a really simple project that has been around. My intuition for making this video is that if you look at this video, I would like you to understand some stuff that is very detrimental for all the future videos, right? So let's begin. In the first initial section, we have some of the imports. Now these imports enable us to do data visualization and data manipulation. Data manipulation is an important step when we are processing unclean data, right? Now in the next code section, with the use of pandas library, I load the dataset, right? This code is used to load the dataset. Whenever you're learning a new library, it's important that you don't tend to memorize a lot of the code basics. You can just refer it whenever you want, right? Moving on, when I load the data and when I look at the data, I can see that there is a car name, a year, a selling price, present year, KMS driven, fuel type, seller type, transmission, and etc. Now you look at this, it is pretty simple and this is a very clean data set, right? Usually data sets do not come this way, right? Because when I check the shape, right, there are 300 column rows. I know this is a lot less. Like most of the data sets that I use and train have like 45,000 to 50,000 rows and limited number of columns, but this is fine. We can make use of this. Now we're going to be looking at all the unique values here. Why do we check the unique values? That we need to set up dummy variables or we need to do one-hot encoding. Both of these problems, if we do not resolve, will lead us to one-hot variable trap, where when you have, let's say, these three specific unique values, petrol, diesel, and CNG, you need to like name them differently. Let's say in the further data sets, I encode them to 0, 1, and 2. What will happen if I mention them to 1, 2, 3? Whenever petrol data is being calculated, if petrol itself is related to petrol, then the data might lead to an error and the model will predict wrong values. To avoid that, to avoid the one-hot encoding is done to avoid the dummy variable trap, right? Next, we check in if there are null values. There are no null values, so we proceed. Next, we describe the data set. Now, this might seem a lot for an initial beginner, but for an experienced person, this means that there is a statistical pattern in the data. And with that, we can do a lot more testing. Now, we would want to like find the current year. The year of the data car is okay. That data can be used for like visual analysis. But that is not quite it when we're doing something else such as regression. We need more data that can be worked around with, right? For that, I set up the current year and I set the number of year parameter. And further, I drop the current year and the year in which the car was sold. This is how the data set looks like, right? Now, further, I will try to drop the selling price. I would like to draw final data set. Yeah, here I use what I call as one-hot encoding. I set up the dummies. Next, I look at the data. I find the correlation between the data I have calculated. I have now pair plots are very, very powerful tools in checking statistical correlation among two variables. If you look at this complex pair chart, here you can see different entities are pair plotted with other entities. Highly correlated values tend to show some patterns. such as this pattern here, this pattern here, right? And other end of the spectrum, when you look at this, this shows very less correlation among both these variables, right? Now here is where I drop the selling price. I set the X and Y. Why do I do that? Is because when I'm trying to train and test the model, I need to set up the data sets. Usually with X, I set up the data where it does not have the column that I need to predict. In my case, that is the selling price. I have the other columns in hand, right? And in Y, I have all the selling price. And with the help of the index, I can make sure what stands corresponds to what. The next step, we do some feature importance tests, right? Where we run an extra tree regressor to find model importance, the features that are important. Here we look at that, okay, number of years is an important parametric. The present price is one of the most important characteristics that are involved in determining the selling price of the car. Similarly, the transmission manual, the fuel type, or the seller type individual, like what are the transitions that the car had before selling and buying. Here we now, again, for machine learning, basic machine learning such as regression classification, there is a powerful library that is known as sklearn or sklearn, right? Can go through all of the documentation online. It is very simple. You can use that to perform all such kind of tasks without having to write complex code, right? Here I'm going to be using a random forest regressor, right? If you don't know what a random forest regressor is, please do check it out and find it what it is, right? Here in this project, I'm aiming to focus how do we do the project rather than explaining each and every aspect of it. In upcoming videos, I will try to make a playlist on different type of models, their characteristics, their not so great characteristics that potentially affects in a production-based environment. For random forest, I'm setting up some parameters that you should need to set up for a random forest algorithm. Here, I initiate the random forest code, and basically before X and Y data, I have split it up with the sklearn module. Now I am passing in that initialized module X and Y, X train and Y train, where the model runs. The model is trying to fit itself to predict the selling price, right? After selling price, we can see that the predicted and the selling prices like correlation statistically, right? Here you can accurately see how close to it has predicted. Like obviously, there are a few outliers, but it tends to perform very closely to what the actual data is. Now for regression, I need to mention about these three main important metrics: the mean, the root mean squared error, the mean average error, the mean squared error. Sorry, the mean absolute error. Both these three of these parameters are important in valuing how well the model performs, right? Sort of like a judgmental metric for regression-based models. So whenever I'm using a lot of regression-based models, I tend to look at all these attributes to judge whether which one of them is best. Right? And again, regression can be done with a wide number of tasks. This is a simple problem, right, where I use just a car prediction CSV to run this. Imagine this being done at scale, right? After training the model, I will save it. I will save the model and I will predict values with that. So that's how a model works. This is a basic introduction to how a machine learning model works. I took up on the topic of regression. This is a simple video. In upcoming videos, I'll talk more about a lot more projects, models, or whatever I mentioned. Upcoming, I will try to do a classification video next to explain how does classification work, the different algorithms involved in it, and etc. And thank you for watching the video. I really hope you understood or gained some information from this. Hope to see you in the next video.